The amount of energy consumed or energy released in a chemical reaction involving catalyst and a chemical reaction involving no catalyst can also be expressed as seen in the diagram here. The picture here represents the reaction pathway for a catalyzed and an uncatalyzed reaction in a typical chemical reaction. The vertical line represents the energy of the reaction, and is a kilojoule per mole. The horizontal line represents the reaction progress, that is, how the reaction progresses. The green line here represents the energy of the reactant at the beginning of the experiment. It is denoted by letter R. Okay, the energy is measured in kilojoule per mole. And likewise, the horizontal line here is the final energy after the reaction. That is the energy of the product, represented by letter P. The energy of the reactant and the energy of the product can be further extended with a broken horizontal line to link one another, just like this. Okay, so this is the reactant, as you can see in the label, and this is the product, as you can see in the label. The difference between the energy of reactant and the energy of the product can be calculated and given as delta H, which is called change in energy, and it is given as delta H is equal to energy of the product, which is the final energy of the reaction, minus the initial energy of the reaction, which is the energy of the reactant, and it's given as is what I call the overall energy, represented by this vertical line, and is denoted as delta H. It can also be done at the other side here. Delta H can also be calculated on both sides, delta H. So the reaction pathway for the catalyzed reaction is represented by the yellow color, and the uncatalyzed reaction is represented by the blue color. Uncatalyzed reaction and catalyzed reaction. The activation energy for these two reactions can also be expressed. The minimum energy that must be possessed by reacting particles before a chemical reaction can take place. And so the activation energy for the uncatalyzed reaction is expressed as the line Y, while the activation energy for the catalyzed reaction is represented by line X. And as you can see the effect of catalyst obviously showing in this reaction profile, the catalyzed reaction has a lower energy profile, while the uncatalyzed reaction has a higher energy profile. So the activation energy for the uncatalyzed reaction is expressed here as labeled and is called EA, activation energy of the uncatalyzed reaction. Then the activation energy for the catalyzed reaction can also be labeled here as EA prime. EA prime. So the catalyst has successfully reduced the activation energy of this reaction as a whole. The impact of catalyst on this reaction profile is obvious. By creating an alternate reaction pathway, this is the alternate reaction pathway. By creating the alternate reaction pathway, which leads to higher proportion of successful collision and resulting in an increase in the rate of reaction.